Our next speaker is Deame, who is the CEO of Nextera Video. They spend a lot of time developing NMOS tools and systems, and I think you'll find his insight really valuable on how to get started with NMOS, launching an NMOS-based system. So take it away, Jed.
All right, well, thank you, Wes. Thank you, everybody, for coming today. So I did a presentation yesterday that was kind of the low-level details of NMOS, kind of walking through the APIs. If that's interesting to you, you can check ipshowcase.org in a week or so and look at that one. This is more of a higher level, kind of customer-focused. I'll go over the basics, but more focused on how to build a system and how to start, getting your hands dirty with NMOS, if you like. As Wes mentioned, we're a supplier of IP cores to help manufacturers add 2110 and NMOS to their products. Okay, so here's our agenda. We're going to talk about what is NMOS, why do I need it, how does it work, what are some of the basic components, why should I care about all this NMOS stuff, and kind of a status report on how it's going with industry adoption. Then we'll get into the example systems and kind of show you what it looks like in the real world and how to put a system together for yourself if you'd like. Okay, well, so what is NMOS? Well, it's yet another acronym. It stands for Networked Media Open Specification. It was developed by the AMWA Group, Advanced Media Workflow Association, to try to come up with a set of guidelines for control for IP-based video systems. So you may recall in the SDI world, every SDI router had their own control system. They're all incompatible with each other. So every system had to make special drivers for everything. We didn't want to do that in IP. We said, even though you might have 100 vendors doing IP systems that are all 2110, let's make sure it's all the same control system. So you can have mix and match between the vendors. What does it do? Well, it enables 2110 devices to seamlessly interoperate. So much like in SDI, you can see the button panels on the right, destination, source, take. So at the end of the day, that's what NMOS gives you, is the ability to just push a button on a control panel and route a 2110 video stream from point A to point B. Why do I need it? Well, it's required. If you want to route something in 2110, it's a required way to do it in a seamless way, like from a button panel. We talked about SDI problems. The alternative, you can do it without NMOS, and in the early days before NMOS existed, it was just a lot of hand editing, a lot of typing in IP addresses into the control system for every device that you had. But NMOS solves those kind of problems. It gives you auto configuration, auto discovery, and full interoperability. So that's really the big thing that's different. We call it plug and play because when the system powers up, every device announces itself to the network and to the control system. I'll talk about how that works in just a minute. So why should I care about all this stuff? Well, system provisioning can be very painful, especially in IP, can be time consuming. There's a lot of information that has to be hand entered and it's very error prone. Plug and play is fun, so why not do it the easy way if you can, right? Let's not make life difficult for ourselves. Most new tenders for facilities are specifying NMOS. A year or two ago, it was kind of an option, quote it both ways, SDI or NMOS. Now we're seeing most new tenders are for 2110 and NMOS. Most control system vendors have fully embraced NMOS as well. There's one or two holdouts, but I've seen some announcements this week at the show, so it looks like you'll have no problem finding a control system from all the major vendors that fully embrace NMOS. And also the EBU wants you to use NMOS. Well, what do I mean by that? Well, there's this document that EBU published a couple of years ago called Tech 3371. It's minimum user requirements to build and manage an IP-based media facility. So the EBU is saying if you want to do IP-based media, these are the things you need to do. For the control area, you need ISO 4, you need ISO 5, 7, 8, and 9. And we'll talk about those in a little bit of detail so you know what all those things are. So how do I know if a product supports NMOS? Let's say you're building a facility or you're building your own lab to do some testing. A good way is to look at the JTNM website. It's a joint task force on network media. It's a combination of SMPTE and EBU, VSF, a bunch of other organizations that got together and said, how can we make it easy for end users to decide if a product will meet their needs and meets all the specifications of 2110 and NMOS? So they do testing. Usually it's twice a year. We had a little slowdown from COVID, but we got back at it about 2 weeks ago at the Riedel facility in Germany. The results were just published a couple days ago. And participants that go in and run all the tests and score well, they earn these badges. There's a different one every year. You see the ones for 2019, 2020, and 2022, the one from just a couple weeks ago. So if you're looking to buy a piece of equipment, you want to see if it's truly interoperable, go to the JTNM website, look at that spreadsheet that they have, and you can see if the piece of equipment has the capabilities that you're looking for. Okay, so how does this NMOS thing really work? Let's kind of walk through a really simple block diagram. Let's say I've got two IP sources on the left. They're cameras, for instance, that might have IP outputs. And then I've got an IP-based monitor on the right, and I want to switch some streams. So let's say we're already connected from the top camera, camera 1, to the monitor, and I want to switch to camera 2. How do I do that? Well, remember I talked about plug and play a little bit. So the way these things work, as soon as you power up any of these devices, they send a set of packets, some information to that registry. Registry is just a piece of software running on a PC, and it's a database. It's got a table of every device. So if you looked in that registry, you'd see it would say camera 1, it's the Sony camera, camera 2, it's a Philips or a Grass Valley camera, and number 3 is say a Sony monitor. So all that information is in that table. It knows all the capabilities. Here's what standards it supports, resolutions, etc. And your control system now can automatically query that, right? It can just send a request and say, hey, Mr. Registry, who's out in my system? Just like your computer does. You don't have to tell it that you have a printer plugged in. It finds it, right? It gives you a list of all the printers. It's the same kind of technology. So the control panel can go look at the registry, and it can even auto-populate the buttons and say, all right, I've got 2 sources and 1 destination. Now I want to switch. So I say destination 1, get source 2, take, right? So what that does, in the old days in SDI, that would actually throw a cross-point switch. But in IP, there are no physical switches anymore. There's just an IP switch. That big cloud in the middle is like a Cisco, Mellanox, Arista switch, for instance. And all the sources are just blasting away at it, sending their IP data. But it holds them until somebody asks for it. So a receiver has to specifically ask for that stream. And it uses that with a technology called IGMP, Internet Group Management Protocol. Is what that stands for. So back to this example, camera 1 is transmitting to the display. We want to switch to camera 2. The display sends a source that says, connect me to camera 2, and by the way, disconnect me from camera 1. So it's just a little packet that it sends to the switch to make this happen. So that's pretty much what NMOS does for you. It's the automatic discovery of the devices and the basic connection management. So that's kind of where we started. So how is it accessed? It's this thing called an application program interface, or software people call them these APIs, but in plain English, that just describes how do I talk to it? Well, I'm using HTTP, just like your web browser does. So if you're going to grassvalley.com or apple.com, that's an IP address that you're connecting to. Well, if you're trying to talk to an NMOS device, he has an IP address. So if I've got a NMOS player and he's at IP address .1, for instance, you just type in your web browser, http:/x-nmos, and then the name of the API, which could be the sender, the receiver, the map, the outputs, security area, and you can see in any web browser what the configuration of the device is. You want to change the configuration of the device, you do an HTTP put, which is just like you're clicking on a form, sending in your information back to a website. So it's a very simple protocol. It's not something super complex. So controllers can get to it, web browsers can get to it. You can do it from the command line. There's a little command line program called curl that allows you to send information to NMOS devices. So very simple. It seems complicated, but there's really not much to it under the covers. So what's a typical implementation? Well, this big thing on the bottom is a product, like a rack mount product is what I'm trying to show there. So in order to do 2110 and NMOS, you have to have a 2110 FPGA core. That's the thing on the lower left. That handles all the processing of the data. You've got your PTP core on the lower right that makes sure that it's all aligned in time. And then you've got the NMOS core, which is usually a piece of software, and his job is to translate the commands from your controller into what the hardware wants. So you can really think of NMOS as just a software layer that abstracts all the complexities of the registers and all the logic that's in this piece of hardware, abstracts it to a very simple web interface with all these /sources, /flows, etc. Okay, so let's dig in a little bit on the components of NMOS in a bit more detail. I've given you the top level overview, but we'll give just a little bit lower level. So the first part of it is ISO4. That's the registration piece. That's the one that says, hey, I'm identifying myself as a device. That's the node API. That means an individual piece of equipment would speak this language, this thing called a node API, and it would talk to the registration API, which is in this registry, this file system, this table that's keeping all the information. And it says, hey, I'm a camera. This is my model number. This is my IP address. This is my capabilities. And then the query API is the one I mentioned earlier. If you're a control system, you can just go and get all that information back and get a list of everything on the network. So this is our plug and play piece, ISO4. Now that I know what all my devices are, how do I connect them? That's ISO5, connection management. So to connect a sender to a receiver in NMOS, we call it an activation. You can call it a connection if you like, but we call it activations. There's 3 types of activations you can do. You can say now immediate, which is what you'd get in SDI world, but you can also do things like relative time, 5 seconds from now, a minute from now, I want you to make this switch. Or you can do an absolute activation. You can say at 12 o'clock, I want you to switch this. So additional capability. And that's kind of the general theme of NMOS is we want to give the end customer the control that he's used to in SDI, but go well beyond that. So not just switch now, but switch in 10 minutes or at a certain time. The next thing we did in NMOS is look at how do we replace the old-fashioned GPIO. So some of you may have spliced cables and run long, contact switch closers to do basic general purpose I/O. An example would be if you have a switcher and you're trying to light up a tally lamp on the camera. Some of you may know that the idea is that if the technical director selects camera 1 on the switcher, you want to light the light on top of camera 1 so the talent knows which camera to look at, so they're not off to the side. So the way tally used to work is you just run a hard cable between the switcher and that camera. Not very flexible, not very convenient. How do we do that in IP? Well, NMOS says, well, we'll just create a new packet structure for that. Works in the NMOS world, and we'll send the packets to the camera to light it. What else do I want to use tally for? Well, I'd also like in my multi-viewer to maybe put a border around the source that's selected as program, or maybe dynamically change the labels. I want to put in camera 1 instead of label 1. So all that's now done with IP instead of the old-fashioned hardwired way. What else does NMOS do for us? Well, ISO 8, that's audio mapping. In SDI world, we had to buy extra cards for our routers. We had to do audio embedders and audio de-embedders, and we could have extra software and map channels around. Guess what? In IP, you get that for free, because in 2110, you've got separate streams for audio, video, and ancillary. So all your audio streams are out there. They're floating around in the cloud. They're sitting in the switch. So a receiver can grab any channel from any stream at once. So we built an API in the NMOS committee to say, how do you actually select that? This is an example, maybe a little more absorbable example that says, I have 2 input streams coming in on the left, stream 1 with channels 1 through 8, stream 2 with channels 1 through 8. and I want to map those to an SDI output. Let's say I'm doing a IP to SDI converter. I want to decide what channels do I embed in that SDI stream. Well, this is what a control panel for something like that would look like. So what I'm actually doing here is an inversion. I'm taking the highest channel and putting it out on SDI1 and the lowest channel and putting it on SDI16. So in this example, we're taking the harmonic signal, which has 16 channels of audio with decreasing amplitude, and we're inverting it in the lower right screen to increasing amplitude. So that's just kind of a practical example of how this audio mapping thing would work. But you could obviously mix and match and move them around any way you like. And no extra hardware, so it's kind of cool. The next thing we do in NMOS is called ISO 9, and that's a system resource. And that's trying to solve the problem of how do I automate sending the same information to a lot of different devices. So one thing you can imagine you might want to do if I had 10 or 20 or 50 or 100 NMOS devices, they all need to know one thing. They need to know what's the PTP domain so they can all be in sync. Well, you could run around and type in the PTP domain in 100 different GUIs, but why do that? Let's just have another service out there using this protocol called DNS Service Discovery. And by service, I just mean a piece of software, again, that's running on a little PC. It could be a NUC PC, it could be a laptop, it could be some other server you have in the rack. And it's providing all this information, the PTP domain, the announce intervals, the heartbeat intervals. And all the NMOS devices are listening for it. As soon as they power up, they're like, oh, is there a DNSSD server out there? Oh, yes, there is. Thank you. Okay, please tell me what protocol I should use. Is it secure? Is it insecure? Is it, and what's my PTP domain? So they instantly get configured on power up. So you don't have to manually do it. Kind of nice. The other thing it does is this first thing on the list, the system ID. What happens when a 2110 NMOS device goes to sleep, gets unplugged, the power goes out? Well, it depends. If you wake up in the same system you were in before, you want to keep doing what you're doing, right? You want to keep outputting the same stream, etc. So it looks at the system ID. If it was 79 on the first power cycle and it's 79 on the second power cycle, it's going to reload its shutdown state. But well, what if you moved it from Studio A to Studio B? You don't want it to wake up in that same state. You're reconfiguring it. You want it to maybe just turn off its outputs. So it'll see, oh, I went to sleep in system 79, but I woke up in system 26. Great, all right. Either restore factory defaults or at least turn off my streams so I'm not blasting the network away on a new studio that's trying to be configured. So a lot of cool things just to make it easy on the system integrator and on the installer. So security, let's talk a little bit about that. As you move to IP, that's the first thing your IT guy will say. It's like, oh, wait a minute, you're moving video over IP, you're doing control over IP, how do we keep this secure? And unfortunately, the answer for the last few years has been, well, we don't. Well, the NMOS committee has been quite busy on this, and we just went through an interop on security 2 weeks ago to make sure that we can add some layers of protection so anybody can't just connect their laptop, the janitor can't come in and plug into your studio network and say, oh, let's route this stream to the on-air feed, right? So the goals of this security program were fourfold. It's first, let's make sure we ensure confidentiality. Any data going between the APIs is not visible by a third party. You can't see what the current configurations are. Identification, make sure that you know that you're talking to a trusted party. That's always good. Integrity, the data hasn't been tampered with. No one's editing the packets as they're going through. And authentication is the packets are actually coming from the controller that you expect or the person that you expect, et cetera. Do you have the rights to do the thing that you're asking it to do? So how does NMOS specify this? Well, in 3 different standards. These are called BCPs, best current practice is what that stands for. So there's the first one, which is the most important one, 00301, that says, don't just use HTTP, right? Web browsers, you are not using HTTP anymore. Most websites are HTTPS, secure, encrypted. Sometimes you'll go to a website and you get a big banner that says, this site is not secure. What that means is they're not using HTTPS. You could actually go in and erase the S and you can still get to those websites, but it's not encrypted. We want to encrypt all the traffic going from our controller to our end devices. So that's what BCP003 does, is it uses this HTTPS secure encryption. Great first start. That's what everybody really should do as soon as they can, because we've just tested those through JT&M and we have a good solution that works. If you want to take it a bit further, you would say, well, I want to make sure that I can authenticate specific users to have specific roles to do certain things. So the TD maybe can do anything, but a tape op or a playback op, he doesn't have control over the on-air destinations, for instance. He only has control over certain destinations. So that's what 00302 gives you, is the ability to have different users and different roles and authenticate all those. And then the third one is a way to provision certificates. Anytime you do security and encryption, you have to have a certificate that assures you're working with a trusted source. And with websites, every website has a trusted certificate, and that's what your web browser does to communicate. Well, if you're inside a facility, you need to have those same certificates, and this is a convenient way of distributing those. So that's a lot of words and talk. Let me just show you a picture. This makes maybe a lot more clear about how it works. So I want to send a signal from a source to a destination, and I want to do it in a secure manner. How do I do it? Well, I need this thing called the broadcast controller, which is my NMOS controller. That's could be your push button routing panel. So there's one new thing we need in the system now. We need an authorization server, and that's the guy that makes sure we're doing what we're supposed to do. So a user types something in the broadcast controller. First thing he does is talks to the authorization server. He says, hey, user 1 wants to connect source A to destination B. So it's a request, and it uses this protocol called OAuth. And the server says, oh, great, he's approved to do that. I'm going to give you this little token, this JWT token. And then with that token, the controller can then send the activation request to the source and say, you're enabled source, here's the token that says this is all legit. But the source goes, well, wait a minute, I'm not sure I really trust you. Let me check with the authorization server. Let me see what his public key is, and then it can authorize that token. So it says, oh, yep, that's a good token. Okay, I'm going to enable my stream. We'll send that to the switch. And remember, all the streams stop at the switch until somebody asks for them. So the second part of the activation is the controller has to tell the destination to ask for the stream using IGMP. He validates it with the key of the server and lets the stream go through. So a few extra steps. There's a lot of stuff going on in the background, but at the high level, it's really simple. You set up your authorization server with all the users that are approved to do certain tasks and certain roles, and then the broadcast controller just checks with them every time. You log into your broadcast controller, those credentials are sent to the server before it lets you do anything. Okay, the next thing we looked at trying to expand beyond basic uncompressed. How do I handle compressed video? So, and I'd like to know from my control panel what sources are compressed and what sources are uncompressed, so I don't accidentally route a compressed stream to an uncompressed receiver. That would be bad. So we added this BCP006 that says, here's how I'm going to identify streams as compressed JPEG XS, and it could be any compression stream, but JPEG XS is in a lot of demand, so we handled that one first. So simple way, by putting this video/JXSV in one of the strings, the controller is smart enough to know who does what. Okay, so that's kind of the basics of NMOS and all the different ISs and BCPs that are commonly used today. There's some more in development, but those probably aren't too interesting. You can look at my other presentation if you want to see what those are all about. So how's it going? Is NMOS being adopted? Is it working well? Well, actually, yes, it's being adopted at a very high level now. It was a little tough going in the beginning for a few different reasons. There were some teething pains. Initially, not all devices supported NMOS. You had some that did and some that didn't. So it was very difficult for the system integrator and the system controllers. They'd have to do special drivers for the non-NMOS ones. But now just about every device out there, I'd say high 90% supports NMOS. And some of the new devices didn't get JT&M testing in the last 2 and 3 years. That was one of the other problems. So people would add NMOS, but maybe it wasn't 100% to spec. But now we've just done another JT&M tested event. So all these people that didn't have a chance to test have been able to test. The third thing, which is probably the biggest thing, is these controllers, these NMOS controllers, didn't actually have a clear way to do interrupt testing and a clear testing process. So that has been added to the JT&M process, and those were all tested 2 weeks ago. And again, you can see the results on the JT&M website. So makes it easy for people to develop code if you've got something to test against. So basically the mitigation is we're doing the testing. We've got some new documentation on the website. This AMWA Info 005 is an implementation guide for all the controller manufacturers. It says this is the way you shall do a controller. This is the way you can maintain compatibility. And they're following that, and they're being tested against it. And if you don't want to wait 6 months for the next tested event, there's automated self-tests available to all manufacturers. So whether you're building a node or you're building a controller, you can download these self-tests and have your engineers confirm that your product meets all the specs before you sell it to your first customer. And if you're an end user, you can double check yourself. You can download these tests and run them on any piece of equipment that you buy and make sure that it does what it's supposed to do. Okay, so how does this testing work? Let's say you wanted to do that. You bought some equipment, you're building a little test lab, and you want to do some testing. Well, there's this thing called the NMOS API testing tool. The URL is right up there, and this will be in the slides and the presentations. It'll be available in a couple weeks on ipshowcase.org. But you download that NMOS testing tool, and this is what it looks like. It comes with this easy NMOS registry, so you don't even need a separate registry. And it just runs through all the tests, and it gives you pass-fails. So you can see how everybody's doing. So let's say you want to build an example system for yourself. What would it look like? And maybe it's a hybrid system. Maybe you've still got some SDI devices. Maybe you want to experiment with some IP components. So I thought the easiest thing would be to show you the system that we actually have in our booth. Oops, this was running too fast. This PC is not very responsive, but there we go. So this is the system we're running in our booth over in 10A26, right across from EVS. If anybody wants to see this, please come by anytime. Like I said, we're right across from the EVS front desk. But this is a hybrid system, so it's got some SDI sources in the top center. Those are coming from Atomos players. We have HD sources and 4K sources, and they're feeding a bunch of 2110 devices on the left side that are mostly gateways. So the SDI is coming into a couple transmitters. There's one from AJA, one from Riedel, and then there's these development boards on the bottom are essentially gateways as well that are converting SDI to IP. There's also some servers on the top that's just a playout device that's putting out 2110. And all these green lines are the IP. These are the SMPTE 2110 IP signals that are going into a switch. And then the outputs of these devices are going into a multi-viewer feeding the multi-viewers on the right. So kind of the minimum you might want is a multi-viewer that shows the outputs. I also show a top IP multi-viewer. If you've got an IP multi-viewer that makes it really easy, you can see all of your sources at once. And then you kind of need another display to look at your output devices. So that's why we have the bottom multi-viewer. And then that little tiny Nook PC towards the center right is what controls it all through a nice little GUI that we're using from Matrox. So let me show you what that looks like. There's also another simple controller you can get called the Riedel NMOS Explorer. This is a nice little utility. It shows you all the devices on your network. It reads the registry. Remember we talked about the registry. It reads all the senders, the receivers, and it lets you drag senders to receivers if you like. It's not super easy to use, but it's very convenient. If you want something a little more user-friendly, the good people at Matrox loaned us their new product called Conduct IP that allows you to very easily build your own control system. In literally 2 minutes, it auto-discovers all the devices on the network in that rightmost column. You can just drag them into this room is what they call it on the left. So we got our transmitters in the first column and the receivers in the second column, and it even has a nice little graphic that shows you who's connected to who. And then it automatically generates this page of senders on this XY routing matrix, which anyone that's done SDI will be familiar with. Senders on the top, receivers on the left. And you just click the buttons and you've made the connections. So about out of time. So the final takeaways are NMOS is here to stay. It's mature. It's in most new products. Control systems are approved. The specs are clarified. A lot of great new features, things we couldn't do in SDI. We've got security, which is amazing. And it makes your control very easy. So I highly recommend that you try it yourself. Thank you very much.